Hi guys and Assalamu alaikum. Welcome to my new blog post 21. And in this blog post, I'm going to discuss about the transactional control language. So let's start. So when I talk about transactional control languages, it means that I'm talking about like TCL is actually used to run changes made by any EML data manipulation language statement. So TCL can be grouped into a logical transactions, and you can say like in every transactional control language we can group various DML statements. Like for example, you can select, update, delete, and upsert merge statements in order to manipulate the data, and you can use the transaction control language. So when you are utilizing TCL or the transaction control language, you will have power to do two things. Like you can actually commit it or roll back it. So what does it mean? Like commit it? It is actually used to save the transaction on the database. So what exactly this means? I'm just going to put a theory right now, but in future posts you will get more elaboration in more visual form. So when I talk about the commit, it means like, for example, I would like to delete the data from the database. I will use the DML statement, but that DML statement is actually enclosed in uh, TCL or the transactional control language. So at the end of the transactional control language, I will utilize the commit statement. First, I showcase it like begin the commit, and then I will actually uh, in the end, I will actually write end that certain commit, right? So between these two committed blocks, there will be the DML statement. So if I succeed to remove the data from the database, so after that I will actually commit the database, commit the transaction. So it means that this committed data is available to everyone who is actually utilizing this database. Meanwhile, if the data is not committed, so no one can see or view the data. Next one is rollback. So the rollback is actually used to restore the data to its original form since it was actually since the last commit. So what does that mean? It means like, for example, I would like to delete the data, but due to some kind of anomaly, I cannot commit the data. So I will actually roll back the certain transaction. It means that I am asking database to go back to its previous past state in which the right commit was present. So this is all about the transactional control language or TCL. I'm positive that you have got the vibe. Please do not forget to subscribe, like, and share my YouTube channel, Yasir Fazal. And please do not forget to hit the bell icon so that you should get the latest video as soon as it is uploaded. And as always, please spread the knowledge. Thank you.
Hi guys and Assalamu alaikum. Welcome to my new blog post 34. And in this blog post, I'm going to discuss about the relation in the relational algebra. So let us start. So first of all, that the question that normally comes into our mind is like, what is a relation? So basically, a relation is a set which actually contains the data in form of tuples and columns. So here I have utilized two terms, tuple and column. So what does that actually mean? So basically, when I talk about tuples, it means rows. So in on the screen, you can actually see there is a table and it contains information. It contains the information about the roll numbers. It contains the information about the sports. So how should we read that information? We can actually read this information in form of tuple and columns. So let's understand the concept of tuple first. So tuple mean like uh, a row in a table, or row in a relation. So both are same, and you can actually and after this video, you can actually easily understand the relation between the row and the word tuple. Tuple always contain heterogeneous information in a relation. For example, on the screen you can see a row contains a textual data as well as a numerical data. How can you actually see that? Like under the roll number, you can see a numeral data. Under the sports, you can actually see textual data. And by combining uh, data sets, or the data values in this set, you can actually get a unique tuple. So this is the definition of a tuple when you actually talk about rows in the relations. Now about the columns. Columns are basically the vertical lines, and column normally contains uh, only homogeneous data. Like it should be a one kind of a data in a relation. For example, the highlighted green vertical lines are actually putting an emphasis on the column sports, and you can actually see that the information that it actually contains is textual, right? So if I do talk about the roll number column, it normally contains only integer values, or the numeral data, right? So it always contains only number data under the roll number column. Any value other than any value of any other type, for example textual type, cannot be entertained under the roll number numeral values. So the relation will be then failed, or it will be destroyed. And that would not be a relation anymore in in the relational database sense, or in the relational algebra sense. So the vertical lines are basically columns, and the horizontal lines in the relation are basically tuples. So you can see that there are four tuples. The first tuple contains the badminton, then the cricket, then the badminton again, and the badminton again. But the roll numbers are making actually are creating a unique pair. Like roll numbers are, first one is the first and the badminton, then the second one is with the cricket, then the second one is third one is has the value of second in the roll number, and badminton in, under the sports column, and then the roll number four contains is making a tuple with badminton, right? So there are four tuples here. And then there are basically two columns, roll number and sports. So the first column contains the roll number information, and sports contain the textual information about the sports. So whenever you need to talk about the cardinality of any relation, it means that the number of rows, number of tuples should be multiplied by the number of columns, which is right now it is 4 multiplied by 2, which is actually 8. So this is the basically the cardinality of the relationship. So I hope so you have understood the concept of the relation through this video. Now there is another thing I have called it like wild questions, the things that I have discussed during the video. So what do you understand by the word tuple? And the second question is, what do you know about the column? And the third question is like, you need to do a bit of research about the cardinality. And as a hint, I have spoken about it in the video, but I have not mentioned about this information in the slide. So please do not forget to answer the questions of these videos in the comment section. Uh, so I should know that you guys have understood the concept. So please do not forget to subscribe, like, and share my YouTube channel, Yasser Fazal. And please do not forget to hit the bell icon so that you should get the latest video as soon as it is uploaded. And as always, please spread the knowledge. Thank you.
Guys, and Assalamu alaikum. Welcome to my new blog post 13. And in this blog post, I'm going to talk about generalization with respect to database, entities, uh, conceptual hierarchy. So let's start. So when we talk about the generalization, just keep one thing in mind that generalization is more like a bottom-up approach in which two or more entities of lower level combine to form a high level entity. So if they have some attributes in common. In generalization, an entity of a higher level can also be combined with the entities of lower level to form a further higher level entities as well. So in generalization is more like subclassing and superclass system, but the only difference is the approach that generalization use the bottom-up approach. And in generalization, entities are combined to form more generalized entities. Subclasses are actually combined to make a superclass. So let's understand this thing, these 4 points with example. For example, I have Toyota, Mercedes, and Tesla. What is actually common in them? Because these are basically cars. So when I actually combine them, so I will get a superclass car. So this is something like something which is actually going to be happen in database as well. Like if I have entities like Toyota, Mercedes, Tesla, I can actually journalize them and put them into one super class named car. So there's another example, like for example, like there's a facility and student are there, and then we can actually can generalize this hierarchy into more higher level entity, for example, person, right? So there are so many examples that we can actually go for them. One more example that I can actually also give you right now is like there are birds, which is actually going to be a superclass, and the subclasses that actually form the birds, like for example, crow, pigeons, and sparrows. So these kind of birds actually can make a one superclass called birds. So this is called the generalization concept. So I am positive that you will get the concept about the generalization in this video. So please do not forget to subscribe, like, and share my YouTube channel, Yasir Fazal. And please do not forget to hit the bell icon so that you should get latest videos as soon as they are uploaded. And as always, please spread the knowledge. Thank you.
Hi guys, and welcome to my new blog post 26. And in this blog post, I'm going to discuss about the concept of the universal set. So let's start. So basically, when we talk about a universal set, it means we are talking about a set that has elements of all related sets without any repetition of elements. So uh, it is normally a set of all sets, and we can say this like the universal set is basically the reflection of its name. A universal set in general terms is basically defined as the set of all objects under consideration, as depicted in the following diagram. A universal set is basically a set that contains all elements or objects of other sets, including its elements. So it is normally denoted by the letter U. So the exact definition of U is basically based on the context of the theory being considered. The elements that normally contained in universal set, which is U, may vary according to the context of the sets being stated. For instance, we might describe U as the collection of all living things on the planet Earth. In this case, the set of all the mammals, or set of all the reptiles, or the set of all the birds becomes a subset of U. Similarly, we can say that the set of all countries in the world is also universal. When we talk about the set theory or the universal set in mathematical terms, the universal set is basically the set of whole numbers. Depending on the context, this set may also be the set of all the shapes or set of all the second degree polynomials and many more. Since a set is a collection of various entities with a common property, The universal set is the collection of all elements relevant to a specific subject. It could be anything like real numbers or a deck of cards to the word inhabitants, uh, and much more. Elements in a universal set are not repeated elements, so all these elements are distinct and unique. So let us go through a example. So considered like we have three sets, namely x, y, and z. So these sets actually have various numbers, right? Like the set x contains 2, 4, 6, 8, y contains 3, 7, 9, 11, and z also contains 4, 8, and 11. If you notice over here, you can see like there are few numbers that are repeated among the sets. Like for example, x and y actually contains uh, nothing unique right now. Sorry, nothing repeated right now. But y and z actually contains some elements which are being repeated. For example, uh, y and z have 11, and x and z has a common element which is actually 4. So when we actually talk about universal set, it means that I am talking about uh, all the numbers which are actually present in this set uh, will merge into a one set and will create a one universal set. So that set would be like 2, 3, 4, 5, 6, 7, 8, 9, 11, and the repetition actually shall be removed, uh, which will be uh, which will create a distinction among the set. So here sometimes we can see that uh, we know that like the universal set contains all the elements of the given sets. Thus the universal set of x, y, and z is here, uh, like which I have shown showcasing you here. So we can see from the solution like that these elements of sets x, y, and z are completely available in the universal set U, and also there are no elements that are repeated in the universal set, and all the elements are unique. By the way, in this universal set U, there might exist another set, for example A, and like since it's not showcased over here, it might be over here. It can be placed over here. But if we say that if there is a set U, which is actually a universal set, then there are three further subsets that are created from this universal set, which are actually x, y, and z. So uh, this is the basic example of the universal set. There is a one distinction that is actually required to be discussed. Like there is a difference between universal set and a union of set. So for this, I will discuss this difference in my next video. Okay. So I hope so you have understood the concept. Hi guys and assalamu alaikum. Welcome to my new blog post 27, and in this blog post I'm going to discuss about the concept of union sets in set theory. So let's start. So when we talk about the union of two sets, what does that mean? It means that we are going to create a final set by combining two or more sets. By default, if you need to have at least two sets in order to create a union of two sets. So maximum can be any number. So let us suppose that we have two sets, and these two sets can contain any kind of number. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till 13 for set A. And then there is a set B, which contains numbers from 14, 15, 16, 17, 18, 19, and 20. So what does that union means? Union means like we are going to combine all these 20 numbers into only one set. So this is called the union of a set, and the resultant set will be named as union. So what shall we get? We shall get A union B, uh, and all the numbers that are actually present. So if we so here is the set A, and here is the set B, the red highlighting button, and the U actually denotes the union of the set, and the resultant set is the is this one till uh, sorry, 1 till 20. I hope so that you have got the concept of the union of two sets. Thank you. Hi guys and Assalamu alaikum. Welcome to my new blog post 29. And in this blog post, I'm going to discuss about the the concept of complements of sets. So let us start with the concept. So when we need to define the complement of a set or set of sets, we it means like we need to create a final set by neglecting one set from another set. So what does that mean? So let us understand this by utilizing a diagram. So I have a set A which contains numbers from 1 to 15, and then there is another set which also contains numbers from 11 to 20. So if I say I need to have a complement of A or the set A, what shall be the complement of set A? It means like I need to write down the values from the set A which are present only in set A, and all the values uh, which are present in set B should be neglected. So in this case, if I say A complement, that would be equals to A minus B, which gives me the answer of the value of values from 1 to 10. So here it means like all the numbers that are present in set A, which are from 1 to 10, should be written down here, and all the values which are common from A and B, which are common in A and B, will be neglected, and all the other values which are actually present in the B but they are absent from the A will not be written in the final set. Same case, if I would like to write down the B complement, it means I need to write down all those elements which are present in set B but they are absent from set A, and all the values from the set A will also be ignored. So utilizing this rule, I will give B complement is equal to B minus A, and values from 16 and till 20 will be written down in as a B complement. I hope so you have understood the concept of the complement of sets. That is a very useful concept and it will be utilized in our SQL queries as well. Thank you.
Hi guys and Assalamu alaikum. Welcome to my new blog post 2, and in this blog post I'm going to discuss about database management system or DBMS in general. So when we talk about database management system, we first need to know about the databases in itself. So basically database is a collection of related data, and data is a collection of facts and figures that can be processed to produce the information. um, the point to be noted over here is like mostly data represents recordable facts. Data aids in producing information which is based on facts. For example, if we have a data about marks obtained by all students, we can then conclude about toppers and the average marks. So basically, when we talk about the DBMS or database management system actually stores the data in such a way that it becomes easier to retrieve, manipulate, and produce the related information. So there are multiple characteristics of database management system, and I'm just going to discuss them one by one. So traditionally, data was organized in various file formats. So DBMS was a new concept back then, and all the research was done to make it overcome the deficiencies in the traditional style of the data management. Right now, in today's world, a modern DBMS has the following characteristics. So first one is like should be a real it acts like a real world entity. A modern DBMS is more realistic and uses real world entities to design its architecture. It It uses the behavior and attributes too. For example, a school database may use students as an entity and their age as an attribute. Next one is relation-based table. When we talk about relation-based tables, DBMS allows entities and relations among them to form table. A user can understand the architecture of a database just by looking at the table names. Then comes isolation of data and application. A database system is entirely different than its data. A database is an active entity, whereas data is said to be passive, on which the database works and organizes. Database DBMS also stores metadata, which is actually data about the data, to ease its own processes. Next one is less redundancy. DBMS basically follows the rules of normalization, which splits a relation when any of its attributes is having redundancy in values. Normalization is basically a mathematically rich and scientific process that reduces the data redundancy. Next one is consistency. Basically, when we talk about the consistency, it's basically a state where every relation in a database remains consistent. There exist methods and techniques which can detect attempt of leaving database in inconsistent state. A DBMS can provide greater consistency as compared to earlier forms of data storing applications like file processing systems. Next one is query language. DBMS is basically equipped with the query language, which makes it more efficient to retrieve and manipulate the data. A user can apply as many as different filtering options as required to retrieve a set of data. Traditionally, it was not possible when we talk about the file processing system. Next one is ACID. So when we talk about ACID, it means atomicity, consistency, isolation, and durability. So these concepts are applied on the transactions which manipulate data in a database. ACID properties help the databases stay healthy in multi-transactional environment and in case of failure. Then it is multi-user and concurrent access. DBMS basically supports multi-user environment and allows them to access and manipulate data in parallel. Though there are restrictions on the transactions when users attempt to handle the same data item, but users are always unaware of them. Then the second last one is multiple views. DBMS basically offers multiple views for different users. A user who is actually in the sales department will have a different view of a database than a person working in the production department. These features enable the users to have a concrete view of the database according to their requirements. And the last one is security. Features like multiple views offer security to some extent, where users are unable to access data of other users and departments. DBMS offers methods to impose constraints while entering data into the database and retrieving the same at a later stage. DBMS offers many different levels of security features, which enables multiple users to have different views with the different features. For example, a user in the sales department cannot see the data that belongs to the purchase department. Additionally, it can also be managed how much data of the sales department should be displayed to the user. Since a DBMS is not saved on the disk as traditional file systems, it is very hard for miscreants to break the code. So this is all about the database management system and its characteristics. In next topic, I'm going to discuss about the users of the database. So hopefully you have liked the video, and please do not forget to subscribe, like, and share my YouTube channel Yasir Fazal, and please do not forget to hit the bell icon so that you should get the latest updates. And as always, please spread the knowledge. Thank you.
Hi guys, and assalamu alaikum. Welcome to my new blog post. 19, and in this blog post I'm going to discuss about the data manipulation language. So basically, when I talk about the DML or the data manipulation language, it means that I'm talking about the user can actually access these DMLs for manipulating the data in the database, and it actually basically handles the user's request. So it means like how can I actually retrieve, how can I actually update, how can I actually merge the data, or can actually call the query language. Uh, how can I actually do that? So the answer is DML. So basically, these are the few commands that actually comes under DML. And the first one is select, and it is actually used to retrieve the data from the database. Next one is insert, and when I would like to insert that, I would like to insert some kind of a data into a table or entity, I will use the insert statement. Third one is update, and it is actually used to update the existing data within a table. Like you don't need to insert the data, you need to update the data, so you will utilize the update statement. Delete, it is actually used to delete set of records that you would like to remove from the table. Merge basically is perform upset operation. Basically, utilizing the merge, you can actually do different kind of upsets, insert or update operation. In more recent form, during utilizing merge, you can also remove the data as well. So you can actually delete the data as well. Then there is a call. It is actually used to call a structured query language or any other program, which is actually lying outside the domain of structured query language. So and the next one is explaining the plan. It has the parameter of explaining the data. It gives you basically it provides you the execution plan of the query. Then there is a log table, and it actually controls the concurrency. It means like when you are actually inserting the data and you don't want anyone to insert the data, you can actually utilize the log table mechanism in order to so that your data can manipulate it, but some other person's data cannot manipulate your data in the data table. So I hope so you have got the point. Please do not forget to subscribe, like, and share my YouTube channel, Yasif Fazal. And please do not forget to hit the bell icon so that you should get the latest videos as soon as they are uploaded. And as always, please hit the watch. Thank you.
Hi guys and assalamu alaikum. Welcome to my new blog post 31. And in this blog post, I'm going to discuss about the concept of subset. So let us start. So when we talk about subsets, it means a subset is a set whose elements are all members of another set. So here is the key all members in this statement. So let us understand this with an example. Suppose I have a set A and it contains three values, namely 1, 2, and 3. Suppose there is another set B which contains two values which are 1 and 3. So it means B is a subset of A because all members of set B are actually present in set A. So mathematically speaking, subset of A could be SA and I name it B. And right here in the example, I'm writing down only one member from a set, only one member in set B, which is 1. And if I say like B is present, all the members of B are actually present in set A, so it holds true for it. So this is the basic concept of subset. So I hope so you have understood the concept. Thank you.
Hi guys and assalamu alaikum. Welcome to my new blog post 20. And in this blog post, I'm going to discuss about the data control language. So when it comes to data control language or DCL, it means that it is actually used to retrieve the stored.saved data. But what does that actually mean? It means like there are so many users that are actually utilizing in the database. So you need to set the authority, like who can actually view what, and who should not view what kind of a data, and at what time they should reviewing it, and at which time they should not review it. So it's more like giving permission to someone, some other user, to view the data, view the stored data. I hope so that you have understood this statement. It's quite difficult to understand, but I am positive that you will understand this. So there are basically two types of data control languages tasks that are actually utilized. First one is grant and the second one is revoke. So when I talk about grant, it is actually used to give user privileges to the database to do some kind of a work. For example, he can select the data, he can update the data, he can delete the data, he can actually execute certain kind of other statements, he can actually insert the data into the database. So these are the permissions that can be granted to certain user, and by this mean you can actually control the data flow which can be utilized, which comes under the umbrella of that user. Now, what would happen like when you don't want to provide uh, grant to certain user, but if he or she already has it, so you will utilize the revoke statement. It is actually used to take back the permission or to take back the power of selection, updation, deletion, or insertion, any kind of execution from the user. So I am positive that you have understood the concept of the data control language. So please do not forget to subscribe, like, and share my YouTube channel, Yasir Fazal. And please do not forget to hit the bell icon so that you should get the latest video as soon as it is uploaded. And as always, please, sorry, and as always, please spread the knowledge. Thank you.
Hi guys and Assalamu alaikum. Welcome to my new blog post 18. And in this blog post, I am going to discuss about the format section of the stack bars chart, which is the first visual that we are currently working in. So here right now, I have populated the stack bar chart with the two dimensions. First one is product and the unit price from the fact table. So it's right now showcasing uh, the data in it. Now I'm just going to discuss the first property of the stack bar chart, which is a general tab. And in that general tab, I will discuss the different subsections of the stack bar chart. So let's start. So our first visualizations, which is actually stack bar chart, if you follow the pointer, you need to go to the format and first section, which is general tab. You will see here three different options. First one is responsive, second one is X position, Y position, width, and height, and then there is a maintain layer order. So I will discuss them one by one. So first one is the one which I'm going to utilize. I'm going to discuss about the exposition. So the what does the exposition mean? So exposition mean it is the x-axis and the vertical starting point of the stack bar chart. So right now it is this point, right? So if I click on it on the stack bar chart, you will see that the numbers over here are actually getting changed. So for one way is like this, like I can actually edit these values as well. And let's suppose I write it like 100 over here, and at the y position, I just write it like 500, 50, sorry. So it means on the vertical x-axis, the starting point of the stack bar chart would be uh, 50, y position would be 50, and the x position would be 100 from from the main point of the screen, from the center point of the screen. Okay, so the next thing is the width. Width means like what will be the total length. Right now, the width is set to the 954 pixels. So I can change them to like, for example, 700. I can edit it, and it will edit with respect to this section on the screen as well. Let me change the height as well. For example, I can put height over here like 200. So it is, the height is also getting changed. So it means like it so you can actually control the dimension of the general tab by utilizing the mouse as per your need, or if you would like to go at a very granular level, you can edit the values in the X position, Y position, and by maintaining the width and the height. So this is the first thing about the general tab, how you can actually control the dimensions. Next thing that I would like to discuss the option about the responsiveness. So what does the responsiveness mean? So again, I need to go to the format section, go to the general section. First, I need to tell you like how the responsiveness will act in this case. So if I turn the option off, and now if I actually make my visual small and small, it is not adjusting to itself right now, and in the end it's just like it's just getting through, it's just getting past, so it's not changing into some sort of an icon or with respect to the screen. So it's just like it's not getting adjusted. It is just like getting smaller and smaller. Now, if I click on the responsiveness side, I and now I need to change it on my screen. You will see that it is actually getting changed. It is getting adjusted to the screen, and sorry, I need to save it. So it's in the end, if the uh, um, if the if your visual is getting very small, it will change into some kind of an icon. So you will experience this information over here. So this is how the responsiveness will work. We will see the more action points about the responsiveness in our future videos, especially when we will discuss about the mobile layout. So after that, we have a third option about maintaining the uh, layer order. So what is that? So let's discuss that first. But before discussion, we need to start about discussing the maintaining order, layer order. We need to discuss about like why do we need that. So for example, in your visuals, you need to showcase your visual in a manner like you need to set a background, and after the background you need to set another background, and on the top of that you need to place your visual. So the thing is, whenever you will click on the background, your upper visual actually goes behind. So you need to keep them, you need to view it on the top of your all visuals, right? You need to keep your background at the base level, and then you need to keep your front view of your visual on the front, on the very front side, or the on the top of the layer. So how you can actually do that? So in order to do that, you can actually utilize the visualizations option of the maintain the layer order. You can actually do that. So you need to turn on the three options, turn on the property for each layer, and you turn on the property for the each uh, visual that you are actually putting in right now. But before moving on to that, how you can actually achieve that even. So for that, you need to go to your uh, modeling, you need to go to the view and you need to click on the selection. Now on the selection side, you will see that I have put the my my Power BI is actually showcasing me the name of the visuals right now. So I have just created the name for like blue layer, orange layer, stack bar, chart layer. So these are just the name of the visuals that I am keeping in. So in order to achieve the maintain layer order, you need to group them. So you need to group them and you need to right click on them. You need to create a group and let's name it like you can actually name it like what would you name it? So just like layer, right? So I just name it as a layer and then I need to turn on the option of uh, maintain layer order. For the stack bar chart, I have already done that. And then if I go to the general tab again, for the orange layer, it is again on. For the blue layer, I need to turn it on again. And now I need to save it. Now, the thing is like, even you have done this, you can't experience the maintenance order over here. It will keep, it will be the same like uh, before, like even if you not if you have not turned it on, it will be same. It will in your Power BI desktop. So how do you can actually experience that? You can experience this through like by going into the home and by clicking it to the clicking on the publish, and once it will be published into your workspace, you can actually experience that. So you need to click on the replace and you need to click on the replace button and the Power BI is actually publishing your report on your workspace. So now you need to move to your workspace. I have already opened it and your report has been published in your workspace. So now you can see like if you are clicking on on the blue screen right now over here or the second layer or on even the stack bar chart, it's not going behind the scene or behind the rectangle, right? So through this you can actually maintain your order. Now what if let's experiment it. For example, if I click on each of the visual and I just close the main maintain layer order. So let's see what will happen. So on the blue layer, so every layer is off now. So I need to click on the save button. I need to go and I need to click on the publish. So once it will be published, we will see what's happening with the report. So now I need to recheck it. I just only need to refresh it. Now you can see like I have just hovered my mouse over the visual and still it's actually getting hidden behind the layer or the visual that I have used as a background. So if I click on I have clicked on the blue layer, so my two visuals are actually getting hidden right now. So this is what happen if you don't utilize the maintain layer order uh, option in the general tab. Hope so you have understood the concept about the stack bar chart. And please do not forget to subscribe, like my YouTube channel, Yasir Fazal. And as always, please spread the knowledge. Thank you.
Hi guys and Assalamu alaikum. Welcome to my new blog post 24. And in this blog post, I'm going to discuss about the set theory. Basically, it's a foundational blog for the set theory, and in coming blogs, I'm going to discuss in detail about the set theory. And in the end of these blogs, I will discuss like how set theory is going to be utilized with respect to databases. So let's start. So first thing I really would like to give you a concept about the set theory. So basically, when I talk about sets, set is basically a collection of distinct objects or distinct elements. These elements or objects that make up a set can be any kind of things like people, letters of alphabet, numbers, point in space, lines, other geometrical shapes, variables, or even other sets. So this is the basic concept about the set and the objects that are related to the set. Common example in the natural world, we can take it as like a fruit basket. Like if there is a fruit basket F, so it may contain various fruits. For example, apple, orange, and grape. Another example is like I would like to see employees from my HR department. Like there is a set which contains employees of various departments, but I only would like to see that employees from the HR department. For example, HR, the set contains Alice, Bob's, and Alice, Bob, and Tommy. Uh, so when I was actually defining the set, I also informed you like uh, it may also contain other set. A set may also contain other set. So it also means like a set may also contain not emptiness as well. So when I talk about the emptiness of the set, that is also possible. Like there is no member in the set, and emptiness is actually the member of that set. So when I talk about an empty basket, it means the basket is empty. There is nothing in the basket as a member. So emptiness is the member of that basket. So this is the basic natural word examples of the set. Let's move towards more mathematical form of the set for defining the set. So if I say like I have a set A and it has various members M, how can I actually write that? So I will simply write A or the set name equals to, and I will actually write down the members enclosed in the curly braces. So whenever I will pick any element from that certain set, I will say like uh, that member actually belongs to A. So MI stands for any member, which is actually in this set. This E it means belongs to the set A. So this is the basic equation of of the set and the related members, which are related to the set. So it is actually a fundamental relation uh, of the set and the related uh, objects or the objects that are residing in the set. So this is the basic concept about the set. I hope so you have understood the concept. Please do not forget to like, subscribe, and share my YouTube channel, Yasir Fazal. Please do not forget to hit the bell icon so that you should get the latest updated videos as soon as they are uploaded. And as always, please spread the knowledge. Thank you. Hi guys and assalamu alaikum. Welcome to my new blog post 3 of SQL series. And in this blog post, I'm going to discuss about the basic users of the databases. So let us start. So as you can see that there are three dummies that I am showing, and they are basically shown as the users of the databases. and they are, and in the center the rotating image is basically DBMS or database management system. So the first one is administrator. So administrators basically maintain the database management systems, and basically they are responsible for administrating the database. They are actually responsible to look after its usage and by whom it should be used. They create access profiles for users and apply limitations to maintain isolation and force security. So database administrators also look after DBMS resources like system licenses, required tools, and other softwares and hardware related maintenance. Next one, which comes in to the play, is basically SQL designers or SQL database developers. So basically, these developers or designers are the group of people who actually work on the designing part of the database. They keep a close watch on what data should be kept and in what format. They actually identify and design the whole set of entities, relation, constraints, and views. So at the database administration and designing part, we actually maintain the security levels, and we also go for analytics and data warehousing concepts. So then, and the end part is the end users, or the basically they are also known as business users. Business users or end users are those who actually reap the benefits of having a DBMS. These users can range from simple viewers who actually pay attention to logs or market rates to sophisticated users such as business analysts. So these users normally see reports. They don't know how the data is being processed or it is being controlled, and which is actually being done by administrators and the SQL report designers or SQL developers. So this is all about the users of database. I hope so that you have understood the concept. So please do not forget to subscribe, like, and share my YouTube channel Yasir Fazal, and do not please forget to hit the bell icon so that you should get the latest video as soon as it is uploaded. And as always, please spread the knowledge. Thank you.
Hi guys and Assalamu alaikum. Welcome to my new blog post, blog 30. And in this blog post, I'm going to discuss about the concept of power set. So let us start. So what does power set mean? It means all possible subsets of a given set, and it also contain empty set. So let us uh, uh, understand the concept of power set utilizing the example. So I have a set A which contains three members, 1, 2, and 3. So when I will create a power set of a set A, it means I will create a set which will contain every possible combination within a set A, including empty set. So power set of A will be power set of A is equal to 1 as a standalone subset of set A, 2 standalone set as a subset of set A, subset 3 as a standalone set subset of set A, and then there will come combinations like 1 comma 2, 2 comma 3, 1 comma 3, and also the set A in itself, 1 comma 2 comma 3, and as I mentioned earlier, empty set as well, which is denoted by the empty curly brackets at the end of a power set A. So by uh, all means, this is the basically the concept of a power set of A. So I hope so you have understood the concept of power set.
Hi guys and Assalamu alaikum. Welcome to my new blog post 3 of SQL series. And in this blog post, I'm going to discuss about the basic users of the databases. So let us start. So as you can see that there are three dummies that I am showing, and they are basically shown as the users of the databases. And in the center, the rotating image is basically DBMS or database management system. So the first one is administrator. So administrators basically maintain the database management systems, and basically they are responsible for administrating the database. They are actually responsible to look after its usage and by whom it should be used. They create access profiles for users and apply limitations to maintain isolation and force security. So database administrators also look after DBMS resources like system licenses, required tools, and other softwares and hardware related maintenance. Next one, which comes in to the play, is basically SQL designers or SQL database developers. So basically, these developers or designers are the group of people who actually work on the designing part of the database. They keep a close watch on what data should be kept and in what format. They actually identify and design the whole set of entities, relation, constraints, and views. So at the database administration and designing part, we actually maintain the security levels, and we also go for analytics and data warehousing concepts. So then, and the end part is the end users, or the basically they are also known as business users. Business users or end users are those who actually reap the benefits of having a DBMS. These users can range from simple viewers who actually pay attention to logs or market rates to sophisticated users such as business analysts. So these users normally see reports. They don't know how the data is being processed or it is being controlled, and which is actually being done by administrators and the SQL report designers or SQL developers. So this is all about the users of database. I hope so that you have understood the concept. So please do not forget to subscribe, like, and share my YouTube channel Yasir Fazal, and do not please forget to hit the bell icon so that you should get the latest video as soon as it is uploaded. And as always, please spread the knowledge. Thank you.
Hi guys and Assalamu alaikum. Welcome to my new blog post, blog 30. And in this blog post, I'm going to discuss about the concept of power set. So let us start. So what does power set mean? It means all possible subsets of a given set, and it also contain empty set. So let us uh, uh, understand the concept of power set utilizing the example. So I have a set A which contains three members, 1, 2, and 3. So when I will create a power set of a set A, it means I will create a set which will contain every possible combination within a set A, including empty set. So power set of A will be power set of A is equal to 1 as a standalone subset of set A, 2 standalone set as a subset of set A, subset 3 as a standalone subset of set A, and then there will come combinations like 1 comma 2, 2 comma 3, 1 comma 3, and also the set A in itself, 1 comma 2 comma 3, and as I mentioned earlier, empty set as well, which is denoted by the empty curly brackets at the end of a power set A. So by uh, all means, this is the basically the concept of a power set of A. So I hope so you have understood the concept of power set. Hi guys, and Assalamu alaikum. Welcome to my new blog post 23. And in this blog post, I'm going to discuss about uh, a TSQL as a dialect to understand. Now, what does that mean? Let's start. So before moving on towards the next slide, I really would like to give you some aspects about the TSQL. Basically, TSQL is based on a strong mathematical foundations, and understanding some of the key principles from those foundations can actually help you better to understand the language you are dealing with. Then you will think in TSQL terms when coding in TSQL as opposed to coding with TSQL while thinking in procedural terms. So why I am saying this, let's understand this with uh, an example. So basically, TSQL is the main language and used to manage and manipulate data in Microsoft main relational database management system, which is RDBMS. SQL Server, whether it's on premises or actually or it's in the cloud, like Microsoft Windows Azure's SQL database. SQL servers also supports other languages like Microsoft Visual C Sharp and Microsoft Visual Basics, but TSQL is usually the preferred language for the data management and manipulation. Then how this TSQL is actually came into the being? This is the big question. So let's see how the TSQL is actually evolved for the Microsoft. So basically, TSQL utilizes two basic components uh, of the workflows. Uh, First one is the set theory, which is the basic set theory that we normally read and write in our mathematics exams. And then there's predicate logic. Now, when you combine predicate logic with the set theory, you will get a relational model. Uh, and this relational model basically gives you the basics of the SQL. This is not the Microsoft SQL. This is the standard SQL. Now, this SQL is basically a standard which is set by ISO, which is International Organization for Standards, and the American National Standards Institute. So this SQL have is actually used to drive uh, the TSQL. The TSQL is basically the dialect of SQL, which is provided by Microsoft. So we can say that, like, if I am talking about Oracle, Oracle is also utilizing the SQL. So the SQL for the Oracle is actually like it will have some its own components, its own functions, and it's a separate direct with respect to Oracle. But it will obviously have to inherit the standard ISO or the ANSI SQL. These two standards for SQL are basically the same. The SQL standards keep evolving with the time, and there are major revisions for this standards, namely, to name few, SQL 86, 89, SQL 92, SQL 1999, SQL 2006, SQL 2008, and SQL 2011, and many more, which are actually coming up. These standard features actually of SQL are normally inherited by various vendors, like for example, Microsoft. And then these features are actually provided in TSQL along with the new features which are actually written by Microsoft or any other or any database vendor, right? So normally, I can say this, like all leading database vendors, including Microsoft, implement a dialect of SQL as the main language to manage and manipulate data in their database platforms. Therefore, the core language element look the same. However, each vendor decides, for example, Oracle or Microsoft, which features to implement and which they don't want to implement. Mainly, most of the time, all of these features are actually provided. Few are not provided. Also, the standards sometimes leave some aspects as an implementation choice. Each vendor also usually implements extensions to the standards in case where the vendor feels that it's important that feature isn't covered by the standard in itself. So normally, it is highly recommended that you need to write your code in a standard way. When you do so, your code is actually more portable. For example, if you write a code in SQL, normal SQL, that code will also run on Oracle as well as on Microsoft. And this makes your knowledge more portable too, because it's easy for you to start working with new platforms. When we talk about the dialect, you are working with the supports both standard and in a non-standard way to do something. You should always uh, prefer the standard form as your default choice. You should consider a non-standard option as well, only when it has some important benefit to you that is not covered by the standard alternative. For example, if Microsoft is providing a very good feature which is actually not available in SQL, standard SQL, then you need to go for the Microsoft SQL. and in many ways you have to. So this is all about like how the SQL is evolved. I'm in further topics, I'm going to talk about relational model, and when I talk about relational model, I mean set theory and predicate logic. So hope so you have liked this video. So please do not forget to subscribe, like, and share my YouTube channel Yasir Fazal, and please do not forget to hit the bell icon, and as always, please spread the knowledge. Thank you. Hi guys, and assalamu alaikum. Welcome to my new blog post 20. And in this blog post, I'm going to give you the basic understanding about the x-axis of the stack bar chart. So let us start. As you can see that on y-axis, I have various products, and on x-axis, I have uh, unit price of these products. So let's start like what kind of changes or how we can actually play with the unit price when it is actually on the x-axis. So when we will actually go to the x-axis, this x-axis is available under the format tab of the visual. So when you will click on this, you will get the x-axis option, and when you expand it, you will actually get various sub options. So let us discuss them one by one. So first option is scale type. This one is linear, and then there is another one which is actually log. So what is actually linear and what is actually log? So first we will discuss about the linear. Linear means like uh, a basic price which is actually starting from the zero, and then there will be various set of unit prices for each product, right? So with respect to those unit prices, you will actually get a lengthy bar like, and on the x-axis, these prices are actually linearly divided, like and it is auto calculated with respect to the maximum amount which is actually present in the visual. So right now it actually created a linear series after automatically analyzing the data on the x-axis about the unit prices, whatever that data is, and it actually has created uh, 7 different intervals, and each interval is basically separated with like 500 value of the $500, which is actually starting from the zero. Then there's a 500, then there's a 1000, then there's 15,000, then 20, then 25,000, and 3,000, and then 3,500. And and after that there is no other value. It means like the maximum value is either $3,500, or it is actually between the 3,000 and the $3,500. And I think this is the maximum value, which is 3 to 6, that is why you are getting the upper limit of the 3,500. So one way is to showcase your data with respect to the linear scaling. It will auto calculate the maximum and the minimum value, and then it will create the intervals, and then it will distribute those values along the x-axis. After that, then there is a scale type of the log. So when you will actually click on the log, it will give you the values with respect to the 10 raised to power. Like 10 raised to power naught is 1. So 10 raised to power naught, or the 0, means $1. Then there is 10 raised to power 1, which is equal to $10. Then the other one is $100, which is actually 10 raised to power 2. And then the series will move on and move forth. And right now it means like the maximum value is 10 raised to power 3, which is equivalent to the $10,000. So here the values are actually distributed with respect to the logarithmic, with respect to the log values. So here distribution is present, but it is with respect to the log. and the log is not of another value, it is the log of the 10, which actually means 10 raised to power, starting from the 10 raised to power 0 till 10 raised to power n. And this all the whole x-axis is basically created by analyzing the data that is provided to the Power BI. So you really don't need to create these intervals. That will be automatically created. Then there is I really would like to switch back to the linear, because further properties will be very easy to explain with respect to that. Then there is a start. So first one is start means like you would like to showcase a value of like road 150 red 48. This is a product, right? So you would like to showcase the value of this product, but it is actually accumulating various unit prices that are actually this is actually accumulating the unit prices of all the units of the road 150 red 48 product, and now you would like to see like you would like to slice the data, like you would like to see the data from a certain point. Like for example, I don't want to see the data between 0 and 500, right? I would like to see the data all the products which actually lies between 2000 and onward. So I can actually see, I will write 2000 over here and see all the products who have the values less than 2000 are disappeared now. You can't see those, none of them, right? And you can only see those products which are actually lying beyond the 2000. Like the minimum value is still there, so 0 is still there, but the value of the bar actually maximizes above the 2000, right? Which is, for this, it is actually 3326, right? Now, what does the end mean? Now, if I say that I would like to see the data like which is going to end within like 2400, so what will happen? So right now it has given me the products which actually lies whom bars or the whom unit prices actually lie between the 2000 and 2400. Now let's say that I would like to see it between 2200. Sorry, 2150. So right now I am actually getting all these products. So let us have another example. Now I say that I would like to see the starting point as 2600. So I am going to put over here, and I will get only those products whose bar are actually maximizing from the 2600 over here, right? And now if I would like to see the end of like 27, so it is showcasing me the values which of those bars which are actually lying between the 2600 and 2700. Again, I can actually invert the axis. Let me clear that one. So here I can actually invert the axis. By inversion means like I will get the same visual, but starting value will be starting from the right. For the dashboard, sometimes it is very useful, but not all the time. So you can actually utilize this inversion axis as per your need. Next one is coloring. So if I say like I would like to choose let's suppose pink, dark pink. So it will change the color of the text to the pink. And I can actually increase the size of the text by clicking on the text size. So it's getting increased. I can also choose the font family as per my need. I have various font options available over here. So I can actually choose the product as it is actually appealing to my audience or the users. Again, I can actually go and opt for the bold. Like for example, I can actually bold these values of the x-axis. I can make them italic. I can actually give them an underline look. Now there are display units. These are actually normally automatically calculated. You can actually give them none. None means is actually the same as auto. And then you can actually utilize the display units in thousands, millions, billions, trillions. So when you will actually convert them into 1000, it means like all the values which are coming over here, they are actually automatically changed to the thousands, million, and it will be automatically calculated with respect to the display units. So for example, if I say trillion, so it has automatically converted the value on of the unit price to the trillion. Right now it is showcasing 0.0000 trillion. The main value is there, but it is not showcasing you right here right now because the original value is is near to zero when we talk about in trillions. So that's why it is showcasing trillion. But the companies who have billions of revenue or even millions, they can actually showcase the trillion. Next one is the title, the properties related to the title. So when I will click on the title, when I will click on the title as off, the title will be not here anymore. When I will click back it to the on, I can actually get this. So style option is like show title only option. So you have no more option available over here. In future, Microsoft will provide style options. So again, the title color. So you can actually choose any color that as it pleases you. Axis title, like if you would like to give the x-axis title over here, you can actually give them. So let's assume like I am giving like values over here. So the default value is changed to the value, the text value that I have given. So also I can actually increase the size. Again, I would like to put it back to the unit price. So let's see if I would like unit price over here. Again, you can actually choose the font family. It could be anything as per your liking, as per your audience liking. And again, you can actually change, you can actually give them a bold look. Why is it not coming over here? It should be showcasing me. Okay, so you can actually have bold. You can actually change the title to the bold. You can give it an italic look. You can also underline it as per your need. Next one is the grid line option. So I can turn it on and I can also turn it off. So what is actually happening over here? So in order to visualize this, let me change the line color to the more appealing color. Let's assume like I would like to give them an orange and strike width I need to increase. And you will see that there are dotted lines that are actually present right now. So this is the dotted line. It is actually showcasing the ranges. It is actually showcasing like where the bar is actually getting intersected at a certain price, like 2000. So this point is basically for this bar, like for this product, Mountain 100 Black 42. At this point, the value is 2000. At this point, the units actually have 1500 value. And then at this point, the value is 1000. So I have various line styles as well, like solid. If I would like to see the correct, I would like to have, I would like to see the values, but in a one glance, I really don't want to think. I will utilize the line style. I have the dotted and the dash as well. So this is the dotted one and this is the dash one. So not much difference. So you can actually change that. And if you don't want to put it, you can actually turn your green lights off. So this is all about the understanding the x-axis properties of the stack bar chart. I hope so you have understood the concept of behind my video. So please do not forget to like, subscribe my YouTube channel Yasir Fazal and this video as well. And as always, please spread the knowledge. Thank you.
Hi guys, and welcome to my new blog series, which is related to the MS SQL Server. I just named it the MS SQL DOS. So in this blog series, I'm going to give you lots of information about the SQL Server and its related variables. So I'm just going to give you a brief overview about our roadmap, like how we are going to take this journey of Microsoft SQL Server. So here it is. So in this blog series, first of all, you will learn about the basics of the database, like what is database, what kind of databases are there, what are the various database types, what kind of data is actually stored in the databases, and things like that. Then we are going to discuss about like how Microsoft SQL Server is related to the term databases, or you may actually say like how is it related to the concept of the databases. We will learn about that. So after that, we will go for like how we can write good queries in Microsoft SQL Server, like what kind of what is actually SQL query writing skill. In this, we will actually discuss about various statements of the SQL, like select statement, update statement, delete statements, how these various CRUD operations are actually performed, and how we can write SQL stored procedures, how can we write views, what kind of user definition functions are there, and things like that. So we will it will contain lots of information which will be related to the queries. After that, how we will move towards like how the administration of MS SQL Server database is administrated or conducted, like how we can actually assign various roles, and how we can actually grant permissions to various users that are going to play with the Microsoft Server SQL database, how we can do migrations and things like that. Then after that, I'm going to tell you about the data warehouses. How can we actually go for like building a database, data warehouse in Microsoft SQL Server. And in this, we will actually discuss about the SQL Server integration services in this, right? And after that, on the top of the data warehouse, how can we build analytics using the data warehouse, which is actually built in SQL Server. So we will learn about the SSAS in these topics, under these topics. So and after that, how we can actually report the data using the Power BI. So this is the roadmap. It's quite a lengthy roadmap, I know, but gradually we will nail down each and every bit of it. So you need to in order to get this information as much as you would like to have, you need to see my blog post. And As always, please subscribe, like, and share my YouTube channel, Yasir Fazal, and don't forget to hit the bell icon so that you just get the latest updates as soon as videos are uploaded. And as always, please spread the knowledge. Thank you. Hi guys, and assalamu alaikum. Welcome to my new blog post 7. And in this blog post, I'm going to discuss about the relational model. So let us start. So when we talk about the relational model, it is the most popular data model in database management system. It is more scientific model than other models, and this model is based on first order predicate logic and defines a table as an array relation. So what does that mean? It means that data is basically stored in tables that are called relations. So this is the table, right? And these uh, each table or each relation have some columns. So columns could be like, for example, in this case, ID, name, class, and section. And when we talk about columns in a relation, it means columns in a relation contains values from a same domain. For example, there is a column ID, and the ID has a atomicity, has atomic value, a unique value, like unique values with a unique data type. For example, 11, 12, 13, 14, and 15, which is a unique numerical data types, or any other data type is actually not allowed in the ID column. So there is a name in which it should have the string values, and then there is a class, again numeric value, and in section there is a single character value. So not a string, but a character value can only be stored in the section column, right? So so the table also contains uh, uh, normalized relations, and which actually used to store the atomic values. So what does that mean? Like each uh, a column holds a name, particular name. So a column ID is basically an attribute, and a name actually is an attribute of the relation. So when we talk about uh, rows or the tuple, each row in relation basically contains a unique value. It means like when you combine the values of different columns in a one row, it will create a unique value in itself. Like 13, Ahmad, 16, and B, basically these are unique value which are absent from any other value, which is actually present in the table. So this is the basically the this is the basic relational model is. And all I will in future blogs I will discuss more about normalization. I hope so you have understood the basic relational model statics from this blog post. So please do not forget to subscribe, like, and share my YouTube channel Yasir Fazal, and please do not forget to hit the bell icon in order to get the latest video as soon as it is updated. And as always, please spread the knowledge. Thank you.
Hi guys, and assalamu alaikum. Welcome to my new blog post 33. And in this blog post, I'm going to discuss about the relational algebra. Uh, these series in these blog posts, which are actually related to relational algebra. This is the first one in the series, so you will get to know more about relational algebra in upcoming blog posts. So let us start with the relational algebra. So first of all, the first thing that actually comes into our mind is like what actually is the relational algebra. So relational algebra is a procedural query language which takes relations as an input and returns relations as an output. So actually we really need to understand like what does this definition mean with respect to our databases or the queries. So when we actually map relational algebra to our SQL queries, the basic thing that we need to understand that in SQL database, the basic point of storage is basically your table. And when we map the term table to relational algebra, it means the relation. So table means a relation. So whenever you perform something by utilizing set theory and utilizing the relational algebra on a relation or a table, you will also get something as an your output, and that would be also a relation. And in SQL terms, you will get a table. So there are basically a few operators, and these are very basic operators which can be applied on these relations to produce the required results that you actually want. So there are six basic operators, and first one is select, which is normally denoted by omega. Uh, then there is project. It is normally denoted by pi. Then there is a union operator, which is normally denoted by U. And then there is a set difference, which is normally denoted by minus sign. And then there is a Cartesian product, which is normally denoted by X. And then the last one is rename, which is normally denoted by phi. So how we will actually apply these basic operations on relations, we will see them in our upcoming blog post. So I hope so you have understood the concept of the relational algebra. So please do not forget to subscribe, like, and share my YouTube channel, Yasir Fazal. And please do not forget to hit the bell icon so that you should get the latest video as soon as it is uploaded. And as always, please spread the knowledge. Thank you. Hi guys, and assalamu alaikum. Welcome to my new blog post 35. And in this blog post, I'm going to discuss about the projection pi in the relational algebra. So let us start. So when we talk about the projection, it means that we need to extract out columns from a certain relation. So how do we write the projection statement? So the basic syntax is very simple. You need to write the word pi over here, and then in the small braces, you need to provide the list of column names that you would like to extract out from the relation. And after mentioning the column names, you need to provide the relation name as well in the curly braces. Once you will actually provide that, you will actually get the result. So let us understand this concept by utilizing an example. So I have a relation which is named as students underscore sports. In this relation, I have the roll number, student name, and the related sports that they are playing. So I need to extract out the roll number column and the sports column. So the syntax would be like pi braces, and in these braces, I'm going to write down the roll number and the sports column name. And after that, I have mentioned the student underscore sports relation or the table. So when I will apply uh, this relation on this table, I will get the roll number and the sports. And as you can see that the student underscore name column is now exempted from the result. And by definition of the relational algebra, it is actually true. And why it is true? Because whenever on a relation, you will apply operation, basic operations, which is actually from the six operations that we have discussed early in my previous blogs. You will also get a relation. So it is right, and it is totally okay with the definition. So I hope so that you have got the basic concept for the term projection in the relations. So coming towards our wild questions. So what should be the projection statement if I need to get all columns? And what should be the projection statement if I need to get only student underscore name column from the relation. So please do not forget to answer the question in the comment section of this video. And please, as always, please subscribe, like, and share my YouTube channel, Yasser Fazal. And please do not forget to hit the bell icon so that you should get the latest video as soon as it is uploaded. And as always, please spread the knowledge. Thank you.
Hi guys and Assalamu alaikum. Welcome to my new blog post 12. And in this blog post, I'm going to discuss about ECH or entities conceptual hierarchy. So let's start. So basically, when we talk about ECH or entities conceptual hierarchical manner, it means that ER model has the power of expressing database entities in a conceptual hierarchy. And as the hierarchy goes up, it generalizes the view of entities. And as we go deep in the hierarchy, it gives us the detail of every entity that is actually included. When I say that going up into the structure, it means generalization, where we are actually clubbed. We actually clubbed together the entities into more generalized view. For example, a particular student name which has a name like Mira can be generalized along with all other students, and the entity shall be a student, and further the student is a person. So the reverse is called the specialization, where a person is a student and that student is a Mira. So basically, this is one approach is like bottom up approach, and the second one is like top to bottom. So when I talk about generalization, it is actually the process of generalizing entities, where the generalized entities contain the properties of all the generalized entities. It is called the generalization when I talk about generalization. In future blocks, I'm going to discuss more about the generalization. So as a basic understanding, in generalization, a number of entities are brought together into one generalized entity based on their similar characteristics. For example, when I talk about birds, so I know if I have a bird, so what kind of a bird it is. Is it a pigeon? Is it a sparrow? Is it a dove? So it's a kind of birds is kind of like it can be generalized into a bird, and then it have a property name or attribute name, pigeon, sparrow, or some or dove or any other bird. When I talk about specialization, specialization is basically totally opposite to the generalization. In generalization, a group of entities is divided into subgroup, and based on their characteristics, take a group like, for example, a person. For example, a person has a name, date of birth, gender, etc. These properties are common in all other persons, human beings, but in a company, person can be identified as a employer, customer, or vendor, or manager based on what role actually they play in the company. So when I talk about specialization, I am talking about like a person can be specialized into more entities as well. So similarly, in school database, persons can be specialized as teachers, students, or staff based on what they play in school as entities. So with this, I actually conclude my ECH concept. So please do not forget to subscribe, like, and share my YouTube channel, Fazal, and please do not forget to hit the bell icon so that you should get the latest video as soon as it is uploaded. And as always, please spread the knowledge. Thank you.
Hi guys and Assalamu alaikum. Welcome to my new blog post 22. And in this blog post, I'm going to discuss about eating soup with a fork in terms of SQL. So why I have written this one? So you actually need to understand this first. Basically, when we talk about the Transact SQL, basically SQL, it is actually the main language which is actually used to manage and manipulate data in Microsoft SQL Server. So a few blocks that are going to be set in future, basically they actually lays the foundation for queuing the data by using the TSQL. So these blocks will actually explain the roots of this SQL, which this language, which is actually TSQL, and the technology and the mindset which basically is required to be adopted by you and actually you write the TSQL code. Then further, I will shift the blocks to describe one of the most important concepts which you actually required, which is actually required by the developer to know about the language, which is actually how the logical query processing works. So now coming towards your now coming towards the question, why shall you eating a soup with a fork? So many aspects of computing, like programming languages, actually evolve based on intuition and the current trend. Without strong foundations, their lifespans can be very short. If they don't survive, often the changes are very rapid due to the changes in these trends. TSQL is, however, different, mainly because it has a strong foundation and mathematics. You don't need to be a mathematician to write a good SQL code, which, if you actually know about the mathematics, it will be an exceptional star in your resume. But as long as you actually need to understand what these foundations are and some of their key principles, you will actually better understand the language you're dealing with. So you actually need to know about the computing, intuition, trend, and strong foundation and the mathematics in order to become a person who can write a good TSQL code. So without these foundations, you can still write the TSQL code, one may ask, but even code that runs actually successfully, but if it hasn't any kind of foundation involved, like it's totally unstructured, then it will be like eating a soup with a fork. So this is the answer. So I hope so you have understood the concept. Please subscribe, like, and share my YouTube channel Yasif Fazal, and please do not forget to hit the bell icon so that you should get the latest updated videos as soon as they are uploaded. And as always, please spread the knowledge. Thank you.
Hi guys and Assalamu alaikum. Welcome to my new blog post 28. And in this blog post, I'm going to discuss about the concept of intersection of sets. So let us start. So what is actually intersection of sets mean? It means like you need to create a final set by taking common members of two or more sets. So here you can actually assume like in order to get the intersection, you always should have like two sets at minimum level. You may have more sets as well, but minimum two is the actually requirement. So how the intersection will happen? Let's see. Let's suppose that I have a one set which contains the set of real numbers from 1 to 15, and I have another set which contains set which also contains the set of real numbers 11 to 20. Uh, so what I'm going to do, just going to take the common elements between these two sets and will create a set which is actually which will be the resultant set or the intersection of these two sets. So the answer is A intersection B equals to 11, 12, 13, 14, and 15. So here you can see like there is a set A, and then there is a set B, and the intersection is denoted by the reverse U sign, or you can say like N, but it's a reverse U sign. And between the parentheses, only the common members are there, which are also present over here in these two sets, which I am creating which I am highlighting on the screen. So I hope so you have got the concept of the intersection of sets. Hi guys and Assalamu alaikum. Welcome to my new blog post 25. And in this blog post, I'm going to discuss about algebra of sets. So it will be a brief overview about the algebra, which is related to the sets. So without further ado, let's start. So we actually know that the algebra of numbers include many operators like addition, subtraction, multiplication, and division, etc. So likewise, algebra of sets basically includes its own collection of useful operators like the operation, like operators of arithmetic. So some of these set operators basically combine two sets and actually yield in a set as well. So uh, we can actually say this like algebra of sets basically defines the properties and laws of sets. The set theoretic operators, operations of union, intersection, and complementation, and relations of set equality and set of inclusion. It also provides systematic procedures for evaluating these expressions and performing various calculations involving these operations and relations which are required to be performed. Uh, so when I talk about like what kind of algebra of sets, algebra that I'm going to utilize on sets. So first one is basically union. So when I talk about union, I assume that there are two sets, and uh, these sets basically belongs to the same universe. Uh, let's suppose U. So the union of A and B actually uh, will will merge into another set, and that will be our resultant set. So it's a theoretical description about the union set. So in future, I'm going to give you a more brief overview about uh, union. Next comes is basically intersection. Intersection means like if you have two sets, but the common members between these two sets actually combine into a one set, and both sets actually do belong to our same universe. So, and next one is the difference. Difference means like you have two sets, but uh, you need to exclude members of one set from another set. So this is just like a subtraction or right or division. Another one is the power. Power means like you need to power set means like if you have a set A and whose members are actually all possible subsets of that set A. For example, if you have a set which has only one member, two members, so it means like it will have 2 raised to power 2 number of sets in it, right? So this is the power set. Another one is Cartesian product of the sets. Like when you multiply two sets with each other, you will actually get the Cartesian product. So this is further going towards the algebra of sets. It means like complement. Complements mean like if a set member, if a set has something which is actually present in it, but you want to have another set which is actually which should have like all the members except the members of A, you will actually utilize the complement. Like for example, if you say like I have a binary set and it has a or it has only one member like one. So the complement of one is normally equals to zero. So it's like that, like something which is actually alternative to that certain set. So we talk about this more in our later slides. Uh, Another one is the equality. Equality means like you have two sets, but those sets must be equal to each other. And then there is a eighth one like inclusion. It means like A is a set and it's a huge set, and then there is a B set, and A actually includes the B itself. Yeah, this is the basically a concept of subset. So one set actually include more sets as well. So by the definition of the set, this is actually true. And you can actually review my last video as well, in which I actually talk about this thing. So I hope so. You have understood the concept of algebra of sets. So please do not forget to subscribe, like, and share my YouTube channel, Yasir Fazal. Please do not forget to hit the bell icon so that you should get the latest video as soon as it is actually uploaded. And as always, please spread the knowledge. Thank you.
Hi guys and assalamu alaikum. Welcome to my new blog post 15. And in this blog post, I'm going to discuss about the inheritance with respect to ECH or entities conceptual hierarchy. So when I talk about inheritance, we will actually use all of features that are present in the entity relationship model in order to create classes of objects. When I talk about more optimistically about the object-oriented programming languages. So these details of entities are generally hidden from the user, and this process is known as abstraction. But when we talk about the inheritance is actually an important feature of generalization and specialization. It allows low-level entities to inherit the attributes of higher-level entities. So let's start with a diagram. So here I have a diagram in which person has different set of attributes. Like a person has a name, age, and gender. So this is more like a generalization. And this person name is this person entity is basically specialized into student and into a teacher. So what I am actually doing here is this, like I have a school database management system, and within a school database management system, I have different set of personals, and that set of personals are actually broken down into student and teacher. Now, the point that is actually required to be here understood is like name, age, and gender are part of person, and the person is being inherited to student and teacher entities. So it is natural to say like name, age, and gender are actually also present in the student and teachers entity. So this is the behavior of the lower part of more like a specialized behavior. Now, when we talk about the specialization, it means like in a specialization with inheritance. It means like all the attributes that are present in the parent class shall be present in the child class as well. So, but child class or child entity can also hold some of its own properties or the attributes. For example, in case of students, they have roll number, which is actually unique to them. It is not required in the parent class, which is actually parent entity, which is actually person. Same goes with the teacher. He has or she has employee ID, and it is not required in the person entity, but it is actually required to put in teacher's entity. So within when we talk about inheritance, all the entities may contain some attributes that are actually personalized to them, and it is not necessary that they will have those attributes will be present in their parent classes as well, or it is not required. So I hope so with this you have understood the concept of inheritance, and please do not forget to subscribe, like, and share my YouTube channel Yasir Fazal, and please do not forget to hit the bell icon so you should get the latest video as soon as it is uploaded. And as always, please spread the knowledge. Thank you.
Hi guys, and welcome to my new blog post 32. In this blog post, I'm going to discuss about the concept of Cartesian product. So let us start. What is Cartesian product? So Cartesian product means that a set which can be fetched by making every possible pair of two elements of two different sets. So for example, I have a set A which contains the value 1, 2, 3, and I have another value, another set B. So B contains two members, A and B. So what I will do, I will create a pair of each value from A with a B with a each with every value from B. So if I say A Cartesian B or A multiply B, it means 1 comma A, 1 comma B, 2 comma A, 2 comma B, 3 comma A, 3 comma B are basically basic Cartesian product of two sets, which is A and B. So I hope so you have understood the concept of Cartesian product. Thank you.
Hi guys, and welcome to my new blog post 8. And in this blog post, I'm going to discuss about entity relational model. So let's start. So basically, when we talk about entity relation model, basically ER model basically defines the conceptual view of a database. It works around like real world entities and the associations among them. At view level, the ER model is basically considered a good option for designing database. So you need to look at your surroundings for the entities, and then you need to associate those entities with each other because they will have some kind of relationship. So when we are talking about entity relationship model, we need to talk about entities first. So let's move towards entity. So what basically entity is? So basically, by definition, an entity can be a real world object, either animate or inanimated, that can be easily identifiable. For example, there's a school database, and students, teacher, classes, and courses offered can be considered as entities, right? And all these entities have some attributes or properties that give them that kind of like their personal identity. An entity set is basically a collection of a similar types of entity. An entity set may contain entities with attribute sharing similar values. For example, student set may contain all the students of a school. Likewise, a teacher set may contain all the teachers of a school from all faculties. So entity sets need not be disjoint. By this means, like when we are talking about like students, so it is quite possible like you are creating a separate entity as a student. So students table could be uh, a student could be a separate table, as well as if you identify teachers as separate identities, so teachers can be also another table within database. So this is the basic, real, small conceptualized concept of entity. Coming towards attributes. So basically, when we talk about attributes, these are basically entities are basically represented by means of their properties, and these properties are called attributes. All attributes have some kind of value in them, and for example, when we talk about attributes, a student entity may have a name, class, age, uh, the courses that he actually studies, attendance, and things like that. So there exists a certain domain or range of values that can be assigned to attributes. For example, a student name cannot be a numeric value. You can't name a person like 1 2 3 4 5 6, and it has to be alphabetic, for example Ahmad or something like that. And likewise, when we talk about a student's age, it cannot be negative. It should always be a positive number. It should be greater than uh, 1, greater than or equal to 1. So when we talk about attributes, there are multiple types of attributes that we talk about. So first attribute, which is being shown on the slide, is simple attribute. So what does that mean? So it means that simple attributes are basically just atomic values which cannot be divided further and For example, when we talk about a student's phone number, it's basically an atomic value. It has certain digits and they cannot be uh, more sliced in order to get the information. Next one is composite attribute. Composite attribute is basically concatenation of uh, two or more simple attributes. So composite attributes are basically made of more than one simple attribute. For example, a student name may have first and last name. So Ahmed and Mohammed is basically these are basically these could be first and the last name of two uh, of one person's name. So when I actually concatenate them or like combine them, I will get a composite attribute which could be Ahmed Muhammad. So next one is basically derived attribute. So derived attributes are basically the attributes that actually do not exist in the physical database. They are actually not in the file, but logically they can be extracted. So you can actually drive their values from actually other attributes that are actually present in the database. For example, you can actually talk about like what is the average salary rate in a certain department, what is the average age factor in a particular class, and you don't need to save this kind of information in the database directly. Instead, you need to store granular information like salary of individual person and salary of ages of students in that database, right? Another example could be like you need to get the age from date of birth. Like if you know the month, date and year of a certain person, which is actually date of birth, so you can extract out the the age of that certain person. Next comes the single value attributes. So single value attributes contain like it contains a single value, uh, for example, social security number or national identification number. But it can be or cannot be a simple attribute because uh, like a simple attribute will always be a single value attribute, but single value attribute, it doesn't necessarily means like it could be uh, it could be possible like it is not a simple attribute. For example, when we talk about national identification numbers, so that can be broken down into multiple meaningful slices. Like you can actually get the pretty good idea about like by looking into the national identification number, you can actually get pretty good idea about like what is the location of that person. Last thing is multi-value attribute. So multi-value attributes actually may contain more than one values. So for example, a person can have more than one phone number, email addresses, home addresses. He may choose multiple courses. A student may choose multiple courses. Teacher is teaching multiple classes. So these are actually multiple value attributes that can be assigned to a certain entity. So these types can actually be combined together as well. Like you can combine simple attribute with the single value attribute and simple value with multi-valued attributes. You can also use like composite attribute with single value attributes and composite with multi-valued attributes. So this is the pretty much simple idea about the entity and respective attributes. So in next blog, I'm going to discuss about the relationships. We have already discussed about relationships in another video, but I will repeat that again. So I hope that you have got the concept of the idea idea of the entity relational model. So please do not forget to subscribe, like, and share my YouTube channel Yasir Fazal. And please do not forget to hit the bell icon so you should get the latest video as soon as it is uploaded. And as always, please spread the knowledge. Thank you.
Hi guys and Assalamu alaikum. Welcome to my new blog post 18. And in this blog post, I'm going to discuss about the DDL or the data definition language in any database. So when I talk about the database data definition languages or shortly DDL, these are actually used to define database structure or pattern. So I would like to define a structure in a database, I will utilize DDL using like create schema, tables, create table, create indexes, create constraints, etc. in the database. I will actually utilize these kind of statements in the database. Using the data DDL statements, you can actually create the skeleton of the database, not the data in itself. So basically, you are creating a metadata. Data definition language is actually used to store the information of the metadata like the number of tables and schemas, their names, indexes, columns in each table constant, etc. So some few tasks that are actually under the hood of DDL are like, for example, first one is create. It is actually used to create object in the database. When I talk about the object, it means any table, any index, any view, any store procedure. So the next word is alter, and it is actually used to alter the structure of the database. For example, I need to alter the table, I need to alter the store procedure, I need to alter the view. Next one is drop. A drop is actually used to delete objects from the database. For example, I need to drop the table. Truncate, it is actually used to remove all records from a table. Uh, so you can actually utilize it to remove all the data in one go from the table. Then another one is renaming or the rename, and this is actually used to rename any object. I would like to rename the table name. I can utilize the rename function. The last one is actually comment. So it is actually just used to comment on the data dictionary or in your code. So these commands are used to update the database schema, and that's why they come under the database definition language. Every language that is actually adopting DDL may have their own flavor of these commands. So I hope so you have got the knowledge about the DDL and have understood the concept. Please do not forget to subscribe, like, and share my YouTube channel Yasir Fazal. And please do not forget to hit the bell icon so that you should get the latest video as soon as it is uploaded. And as always, please spread the knowledge. Thank you.
Hi guys and Assalamu alaikum. Welcome to my new blog post 6. And in this blog post, I'm going to discuss about the entity relationship model. So let's start. So before explaining the diagram, I need to elaborate something. Entity relationship model is actually based on a notion of a real world entities and relationships among them while formulating real world scenario into the database model. The entity relationship model basically creates entity set, relationship set, and general attributes and various constraints. ER model is best used for the conceptual design of any database that is required to be designed. Entity relationship model is basically based on two things. Number one is entities and respective attributes and the relationship among the entities. So let's explain this diagram now. So in this diagram, I have two things. One is T-Rex and second one is ice cream. So basically, what I am trying to say over here is like entity is T-Rex and ice cream is basically another entity. So as I said, like in the real world, so in real world, there are two entities, ice cream and T-Rex. So both have some common attributes with respect, both have some attributes and these attributes could be for T-Rex, it is its color, its smell, its weight, its speed. And for ice cream, the attributes would be color, level of tastiness, flavors, and the price of the ice cream, right? So how these two entities are basically related to each other, because we have defined the entities and the attributes, but the relationship is basically missing over here. So the relationship over here is like T-Rex would like to eat the ice cream. I know it's quite a separate thing that what I am saying, but I haven't found the meat for the T-Rex. So T-Rex is actually obliged to get the ice cream. So basically, when we talk about entity relationship model, we are talking about two entities or more entities and the relationship among them or between them when we are talking about the two entities. So this is something about the entity relationship model. So you need to understand a few things that we have concluded from the diagram. Is like entity is basically in ER model is a real world entity having properties called attributes, and every attribute is defined by its set of values called domain. For example, when I talk about database, let's assume that I am creating a school database, and then there will be students, and the students are considered as entity. Students has various attributes like name, age, class, etc. So here I am talking about the T-Rex, and the T-Rex have various attributes that I have elaborated earlier. Then there is a relationship between the entities. So this is the logical association among entities, and it is normally called as relationship. Relationships are basically mapped with entities in various ways, and mapping cardinalities define the number of association between two entities. So when I talk about mapping cardinalities, what does that mean? So there are basically four cardinalities. So first one is one to one, like there's one entity and then there is a second entity, and the first entity, which is T-Rex, and the second entity, which is ice cream. One T-Rex would like to eat only one ice cream. So this is one to one. When we are talking about two relationship between the two entities, this is one to one relationship. Next is one to many. Like there is one entity of the T-Rex, and then there are multiple entities of the ice cream. And one T-Rex would like to eat many ice creams. Next one is many to one, and there are many T-Rexes, and there is only one ice cream, poor ice cream, and the four T-Rexes. So many T-Rexes would like to eat only one ice cream. So there is another cardinality, which is the fourth cardinality. It is basically many to many. And when we talk about many to many, it means like many entities like T-Rex would like to eat many ice creams, like um, many ice creams, and this relationship would be called many to many. So I hope so that you have understood the concept of the entity relationship diagram and the related mapping cardinalities. So please do not forget to subscribe, like, and share my YouTube channel, Yasir Fazal. Please do not forget to hit the bell icon so that you should get the latest video as soon as it is updated. And as always, please spread the knowledge. Thank you. Hi guys, and assalamu alaikum. Welcome to my new blog post 9. And in this blog post, I'm going to discuss about the database schema. So before moving further towards like database schema, I really would like to give you a basic definition about the database schema. So when we talk about the database schema, basically database schema is the skeleton structure that basically represents the logical view of the entire database. It defines how the data is actually organized and how the relations among them are actually associated with it. So basically, it formulates all the constraints that are to be applied on the data. So the database schema defines its various entities and its relationships among them. It contains a descriptive detail of the database, and that can be depicted by means of schema diagrams. Uh, it's the database designers actually who actually design the schema to help other programmers to understand the database and try to make it useful. So when I use the database schema, I mean like there are two types of schemas when it comes to studying about the database schema. So first one is basically the physical schema. So
physical database schema is basically the schema that actually pertains the actual storage of the data and its form of the storage, like files, indexes, uh, your various physical tables that exist on the hard disk, or where the data is actually being stored. So it actually defines how the data will be stored in the in a secondary storage, like what would be the format system of the data or the database file. Then when we talk about the physical schema of the database, we need to talk about like what is the logical schema. So this is the basically the second type of database schema that I am talking about right now. So basically this schema defines all the logical constraints that need to be applied on the data which is stored. For example, a data of student is actually stored in the hard disk or in the physical schema in file structure format, but how that data would be organized. For example, the data of the student is contains the student ID, student names, student age, student address, in which class it is actually enrolled into. So this kind of logical structure will be defined under the logical schema. Above the logical schema, when we need to get the data, we need to talk about the views, like how that data would be read, like for how that data would be that data which is actually categorized into the various forms of logical schemas, how that data could be viewed for the database programmers or for the programmers who are going to utilize the data. So on the top of that, we will create a view of that logical database. It will contain your various kind of functions, SQL functions, SQL views, SQL stored procedures, or things like that. Those will be the part of your view. So hopefully you will understood the concept of the database schema. So as always, please subscribe, like, and share my YouTube channel, Yasser Fazal, and please do not forget to hit the bell icon so that you should get the latest updates as soon as the video is uploaded. And as always, please spread the knowledge. Thank you.
Hi guys and assalamu alaikum. Welcome to my new blog post 17. And in this blog post, I'm going to discuss about database language. So when I talk about database language, it means like it's a mode of a communication between you and the database. So whenever you will write some kind of you need to write data into the database file, you will utilize the database language in order to do your work. So these database languages are basically appropriate languages and interfaces to express database queries and updates. These are the queries and updates are basically your instructions that are actually going to your database and retrieving and inserting and fetching and deleting the data. These database languages actually utilize to store, read, and update the data in the database in a nutshell. So with respect to functionality of the database language, any database language, they need to perform four main functions. Or DBMS language is actually subcategorized into four languages. So first one is DDL. This is actually the data definition language, and it is used to define the database structure or the pattern of the database. Next one is DML, which is actually data manipulation language, and it is used for accessing and manipulating the data in the database. So mainly the user is actually utilize these DML parts to perform their bids, right? So next one is data control language, and it is used to basically retrieve or store retrieve the stored or saved data which is actually present in the database. So these are so the last one is TCL, which is actually transaction control language, and these are used to run the changes that are run the changes made by the DML statements. In future blog posts, I'm also going to discuss these four types in more detail. So hope so you have got the concept about the database languages. Please do not forget to subscribe, like, and share my YouTube channel Yasif as well. And please do not forget to hit the bell icon so that you should get the latest video as soon as it is uploaded. And as always, please spread the knowledge. Thank you.
Hi guys and assalamu alaikum. Welcome to my new blog post 10, and in this blog post I'm going to discuss about the database instance. So let's start. So when we talk about the database instance, basically what I actually mean is like a database instance is basically a state of operational database with data at any given time. It basically contains a snapshot of the certain database, and database instances tend to change with respect to time. DBMS basically ensures that it's every instance or the state is actually in a very valid state by diligently following all the validations, constraints, and conditions that the database designers have imposed. There is a when we talk about the database instance, we also need to understand about the database schema. It is very important that we should distinguish these two terms individually. So I'm just going to talk about the differences between the database schema and the database instance. So when we talk about the database schema, basically it is the skeleton of the database, and it is designed when the database doesn't even exist at all. Once the database is actually operational, it is very difficult to make any changes to it. A database schema does not contain any data or information. On the other hand, the database instance does contain information and the data. For example, as we can see in the slide, like when I talk about the schema, it means like there are three tables like course, student, and grade, and then there are columns that are actually defined in it, that are actually defined in these tables. For example, course contain course name, course ID, and department. A student actually contains name, ID, course, and semester. And then there is a grade table which actually contains the ID, semester, course, and grade. So this is basically the schema of the database. It is actually defining the data structure of the database. Whereas when I talk about the database instance, it means like the course will contain the information within its columns. Like for example, there shall be many courses like maths, English, um, biology, physics, chemistry. So these are basically course names, and this is actually the data. So this is the data that will be captured by any database instance. So this is this is the basic difference between the database instance and the schema. So further, I can say like once you actually declare a schema for a database, it won't get frequently modified as it distributes the organization of data in the database. On the other hand, instance basically updates frequently. Also, data definition statement specifies the generation and modification of schema. And on the other hand, DML statements basically specify generation and modification of data inside the database. So when I talk about the DDL statements, it's like about creating a table, like create statement of the table, dropping a table like drop table. So these are the statements that are defined under DDL, and there are many statements like this, and we will discuss them in near future. On the other hand, I will when we talk about the DML statements, it means like update statement or uh, delete statement or truncate statement. So these are basically data manipulation statements, and these are actually utilized to change or alter the database instances. So uh, conclusion is this: like whenever you think about creating a database, you have to create a schema that would define the outline of for the formation of a database. And a good schema is able to generate a good database, and schema should be created carefully, as frequent changes are not accepted in the schema and may cause problem, right? So hopefully you have understood the concept, and please do not forget to subscribe, like, and share my YouTube channel Yasir Fazal, and please don't forget to hit the bell icon so that you should get the latest updated video as soon as possible, as soon as it is going to be uploaded. And as always, please spread the knowledge. Thank you. Hi guys, and assalamu alaikum. Welcome to my new blog post 4. And in this blog post, I'm going to discuss about the database management system architecture. So let us start. So before deeping dive into the main topic, I'm going to discuss about some important points that are related to the database design. So when we basically talk about the design of a database management system, it strictly depends on its architecture. This architecture could be centralized or decentralized or hierarchical. So basically, you need to understand this, that like the architecture of a DBMS can be seen as either single tier or multi-tier. And N-tier architecture divides the whole system into related but independent end modules, which can be independently modified, altered, changed, or replaced. In one tier architecture, the DBMS is the only entity where the user directly sits on the DBMS and use it. Any changes done here will directly be done on the DBMS itself. It does not provide any kind of handy tools for end users. Database designers and programmers basically prefer to use the single tier architecture. If the architecture of the DBMS is two-tier, then it must have an application through which the DBMS can be accessed. Programmers use basically two-tier architecture where they access the DBMS by means of any kind of application. Like for example, an application which is written in C# and it's providing a communication with SQL Server, which here is a DBMS. Here, the application tier is entirely independent of the databases in terms of operation design and programming. So when you accumulate first one, two, and multiple tiers, you will get the N-tier architecture. So the most commonly database architecture which is being used nowadays is basically three-tier architecture. When we are basically talking about we normally talk about the relational databases. So let's start with this one. A three-tier architecture separates its tiers from each other based on the complexity of the users and how they use the data present in the database. It is mostly widely used architecture to design a database. So first tier is basically the database or the data tier. At this tier, the database resides along with its query processing language. For example, SQL. We also have the relations that define the data and their constraint at this level. By defining the data means like tables, views, functions, and the constraints like foreign key constraint, unique constraints, primary key, and things like that. And then this database tier is basically connected to your application tier. At this tier reside the application server and the programs that access the database. For a user, this application tier presents an abstracted view of the databases, and users are unaware of any existence of the database beyond the application. At the other hand, the database tier is not aware of any other user beyond the application tier. Hence, the application layer sits in the middle and acts as a mediator between the end user and the database. Then on the top of it, we get presentation tier or the user tier. End users basically operate on this tier and they know nothing about any existence of the database beyond this layer. At this layer, multiple views of a database can be provided by the application. All views are generated by application that reside in the application tier. Multiple tier databases architecture is highly modifiable as almost all of its components are independent and can be changed independently. So this is all about the database architecture. I hope so that you have understood the concept. So with this, I would say, like, please subscribe, like, and share my YouTube channel, Yasser Fazal, and do not forget to hit the bell icon so you should get the latest updates as soon as new video is uploaded. And as always, please spread the knowledge. Thank you. Hi guys, and Assalamu alaikum. Welcome to my new blog post 5. And in this blog post, I'm going to discuss about the data models. It's just going to be a brief interview about the data models. So let's start. So what basically are data models? So basically when we talk about data models, and data models basically define how the logical structure of the database is basically modeled. These are actually data models basically define the fundamental entities that actually introduce the abstraction in a certain management system, for example, database management system. Data models basically also define how data is basically connected to each other and how they are processed and stored inside any system. The very first data model could be a flat data model where all the data used are to be kept in the same plane. Uh, Earlier, when the models were being developed, they were not so scientific, hence they were prone to introduce lots of duplication and update anomalies. So let us discuss about different types of data models. So first type of the data model is basically conceptual data model. So the conceptual data model should be used to organize and define concepts and rules. Typically, business stakeholders and data architects will create such a model to convey what system actually contains. Then, in contrast to the conceptual data model, there is basically logical data model in which physical data models basically are connected, are concerned with how such system should be implemented. Like the conceptual data model, the logical data model is also used by data architects, but also will be used by a business analyst with the purpose of developing any database management system, any kind of management system, agnostic technical map of rules and structures are basically part of the logical data models. And then the third one is the physical data model, which is actually used to demonstrate the implementation of system using a specific management systems, typically database management system, and is typically used by the database analyst or any kind of analyst and developers. So this is a small brief introduction about the data models. So I hope so you have liked this video. So please do not forget to subscribe, like, and share my YouTube channel Yasir Fazal, and please do not forget to hit the bell icon so you should get the latest updates as soon as my video is uploaded. And please do not forget to spread the knowledge. Thank you. Hi guys and assalamu alaikum. Welcome to my new blog post 11, and in this blog post I'm going to discuss about the data independence. So let's start. So when we talk about the data independence, we actually talk about a database system which normally contains a lot of data in addition to the user's data. For example, it stores data about the data known as metadata to locate, retrieve data easily. It's rather difficult to modify or update a set of metadata once it is actually stored into the database. But as the VMS expands, it needs to change over time to satisfy the requirements of the users. If the entire data is actually independent, it would becomes a tedious and highly complex job. So data independence is basically categorized into two types: logical data independence and physical data independence. So let us discuss both of them one by one. So when we talk about the logical data independence, it applies on the logical schema. So when I mean like when we talk about the logical data independence, it means logical data is actually the data about the database. Actually, it is the metadata. It actually stores the information about how data is actually going to be managed inside the database. For example, a table relation stored in the database and all its constraints and applied that are going to be applied on that relation. Logical data independence is kind of mechanism which basically liberalizes itself from actual data stored on the disk. So if we do some changes on the table format, it should not change the data residing on the disk. Uh, on the so you can say like logical data basically logical data independence refers characteristics of being able to change the conceptual schema without having to change the external schema. Uh, Also, this independence is used to separate the external level from the conceptual view. So if you do any change in the conceptual view of the data, then the user view of the data would not be affected. And logical data independence occurs at the user interface level. In comparison to the logical data independence, we have physical data independence, which actually applies on the physical schema. So what does that mean? It means like all the schemas that are actually logical and the actual data is actually stored in a bit format on the disk, hard disk. Physical data independence is the power to change the physical data without impacting the schema or logical data. For example, in case we want to change or upgrade the storage system itself, suppose we want to replace a hard disk with SSD, it should not have any impact on the logical data or schemas, right? So it means like physical data independence can be defined as the capacity to change the internal schema without having to change the conceptual schema. If we do any changes in the storage size of the database system server, then the conceptual structure of the database will not be affected. Physical data independence is basically used to separate the conceptual levels from the internal levels. Physical data independence occurs at the logical interface level. So hopefully you have got the point about the database independence. uh, so please do not forget to subscribe, like, and share my YouTube channel Yasir Fazal, and do not forget to hit the bell icon so that you should get the latest updated video as soon as it is uploaded. And as always, please spread the knowledge. Thank you.
So when I use the term anomaly, it means that while designing a database, I made some kind of a mistake and database design is actually not perfect. And it may contain some problems which can be called as anomalies, which are like a bad dream for any database writer, programmer, a person who is actually managing a database with anomaly is actually next to impossible. So there are three kinds of anomalies theoretically. First one is update anomalies. So if data items are actually scattered and not linked to each other properly, for example, when I talk about the link, there's a primary and foreign key relationship between the entities and that link is absent, then it could lead to the strange situation. For example, when we try to update one data item, having it copies scattered over all several places, a few instances get updated properly while a few others are left with old values. Such instances leave the database in is in an inconsistent state. Uh, then there is second one is deletion anomalies. So we try to delete a record, but parts of it was actually left undetected because of unawareness. The data is also saved somewhere else. It acts like same like update anomaly, but in a manner like in update we are actually updating a value for a record. And in deletion, we are actually removing the information of certain record from the database file in itself. And the other one is insert anomaly. So we try to insert the data in a record and that does not exist at all. For example, I have a primary key foreign key relationship between two tables. And in order to insert data in one table, which is actually table B, whenever I try to insert some kind of a data in table B, I actually get an insert anomaly because the parent table does not contain the parent row for the table, parent row, which is a parent row in the parent table, table A. So you can't actually insert the data in this. So if the proper primary key foreign key relationship is not made here, the data will be inserted into table B, but since there will be no relation between table A and table B, the data should not be inserted, but it is actually inserted and it will be acted as a orphan record. And it can lead up to like updated anomaly and deletion anomalies. So when I talk about anomalies, how can we actually remove them? We actually utilize normalization, and normalization is actually a method to remove all these kind of anomalies and bring the database into a consistent form. So just to briefly describe here, I'll give you a bird's eye view about the normalization process. So there are basically 3 steps in normalization in which data is actually transformed into first, second, and third normal form. In future blocks, I will discuss the normalization in detail, but for now on, it is all about the anomalies, and hopefully you have understood the concept. So please do not forget to subscribe, like, and share my YouTube channel, Yasir Fazal, and please do not forget to hit the bell icon so that you should get the latest updated video as soon as possible, as soon as it is uploaded. And as always, please spread the knowledge. Thank you.